So in this video, we're going to solve inequalities in one variable. So this means we're going to have solutions that are intervals on the real number line. They're usually intervals. Sometimes you can get isolated points as well. Example, solve the inequality x minus 2 times the quantity x plus 1 times the quantity x plus 3 is greater than or equal to 0. So my zeros are at 2, minus 1, and 3, and they're all solid dots because of the equals in the greater than or equal to. So I'm going to graph those on a number line in the correct order, -3, -1, 2, left to right. And then what I want to do is check test points in each of the 4 intervals that defines to see which intervals include the solutions of the inequality, which in this case are all intervals. So I chose -4, -2, 0, and 3 just because those were simple numbers in between my endpoints of the intervals. So I would write out exactly what I have here. X equals -4 colon, and then write out, I just wrote out the signs because I don't care what the numbers are because we're comparing it with 0. We just want to know, is it positive or negative? So if I put -4 in here, I get -6, which is negative. -4 in here is -3, so it's negative. -4 in here is -1, so it's negative. Product of 3 negatives is negative, and we want positive. So I put no there. And that means I'm not going to shade in this region that includes -4. And then I move on to do the same thing with -2. And I get a positive number. And so I'll shade in that region that contains -2, which is this region here. Right. Do the same thing with 0. I get a negative number, so I don't want to shade in that region. And then I do the same thing with 3, and I get all positives, which is positive. And so I will shade in that region to the right of 2 there, where 3 is, right in there. Okay, so I'll just draw the number line as it is now. Usually people just use the same number line, but I'm just writing a second one for clarity. So I get those intervals, and then I write them in interval notation. And that's that.